Numbers, patterns, and insights. This is the beating heart of data science, and it all starts with exploratory data analysis. If you've ever wondered how to unravel the hidden stories behind rows and columns of data, you're in the right place. Welcome to Day 5 of the 30 Days of Machine Learning series, where we transform complexity into clarity. If you're just joining, don't worry. You can click right here to access the full playlist and catch up on every step of the journey so far. In the last video, we touched on the basics of EDA, like understanding distributions and spotting outliers. But today, we're leveling up. It's time to unlock original EDA techniques that take your analysis to the next level. The dataset? We'll be working with IPL data. Let's dive in. We're loading pandas, NumPy, Matplotlib, and Seaborn, essential tools for efficient data handling, analysis, and stunning visualizations. Now let's load our datasets. Matches.csv for match details and deliveries.csv for ball-by-ball data. Time to explore. Let's preview the first few rows of both datasets. Matches data and ball-by-ball deliveries data. Now let's check the structure of both datasets to understand the data types and null values. Let's check for missing values in the umpire 3 column and inspect the last 10 entries for insights. Time to get some summary statistics of the matches DF and find the highest match ID for reference. Let's explore the unique seasons in the matches DF. Here we're identifying the match with the largest margin of victory by runs. Let's see which match that is. Now let's find out which team won by the largest margin of runs. Let's check the winner. Next, let's identify the team with the biggest win by wickets. Let's check out the winner. Here, we're finding the team with the highest win by wickets, excluding 0 values. Let's see who it is. Now we're getting the full details of the match with the highest win by wickets, excluding zeros. Let's take a look. Now let's visualize the number of matches per season using a count plot. This will give us a clear view of match distribution across IPL seasons. Here, we're plotting the number of wins for each team using a horizontal bar plot. This will show us the most successful teams in IPL history. Now let's visualize the count of matches played at each venue using a count plot. Rotating the x-axis labels helps us read venue names easily. We're reshaping the matches.df using melt to combine Team 1 and Team 2 into one column. Then, we use a count plot to visualize how often each team played. Rotating the x-axis labels helps read the team names clearly. Here, we're plotting the frequency of wins by each team using a count plot. The vertical rotation of the x-axis labels helps us clearly read the team names. We're now creating a temp.df that captures the winner of each season by dropping duplicates based on the season column. This will give us a summary of IPL season winners. Now we're visualizing the toss decision percentages using a pie chart. First, we calculate the frequency of each toss decision from the toss decision column and convert those frequencies into percentages. The pie chart clearly shows how often teams choose to bat or field after winning the toss in IPL matches. The Auto PCT option displays the percentage of each decision on the chart, and the shadow effect adds a nice touch to the visual. This gives us a quick insight into how teams prefer to start the game. We're visualizing toss decisions by season with a count plot, where each season is split by bat or field. Rotating the X-axis labels makes it easier to read. Let's check out the trends. We're visualizing the win percentage for teams batting second using a pie chart. First, we calculate the number of wins by checking where win by wickets is greater than 0, indicating a win when batting second. Similarly, losses are counted when win by wickets is 0, meaning a team lost while batting second. These values are then converted into percentages to represent the win-loss ratio. The Auto PCT option ensures the percentage is displayed on the chart, and the shadow effect adds a nice visual touch. This helps us understand how often teams succeed when chasing. We're creating the auto label function to add text labels above each bar in a chart, showing the value of each bar. The getEx function and getWidth function calculate the position, while productWithHeight ensures the label is placed just above the bar. In this code, we're diving into the Player of the Match award data to identify the top 10 players who've received the award the most. We start by calculating the value data counts of the Players of Match column, which tells us how many times each player has been honored with the award. We select the top 10 awardees using slicing and store them in temp series. Then we create a bar chart using AxBar with a width of 0.9 for each bar and the color set to yellow for a clean, visually appealing look. The X-Tick labels function rotates the player names vertically so they fit comfortably on the X-axis. The auto-label function is applied to place the exact count value just above each bar, making it easy for viewers to see the exact number of times each player received the award. This chart offers an insightful look into the most consistent and outstanding performers across seasons, showcasing the players who've been recognized the most as the player of the match in IPL history. In this code, we're visualizing the top umpires by counting the appearances of each umpire in the Umpire 1 and Umpire 2 columns. We melt the data frame to combine the umpire columns into one, then calculate the top 10 umpires using value card counts. The bar chart is plotted with red bars, and player names are displayed vertically for better readability. Using the auto-label function, we show the exact counts above each bar. This visualization helps us identify the most frequently appearing umpires in IPL matches. In this code, we're visualizing the top run scorers in the IPL by calculating the total runs scored by each batsman. We group the data by batsman and aggregate the total runs using AgSum. Then we sort the batsmen in descending order based on their total runs and reset the index. After selecting the top 10 batsmen, we create a bar chart using AxBar with blue-colored bars. The batsman names are rotated vertically to fit comfortably on the X-axis. Using the auto-label function, we display the exact number of runs above each bar for better clarity. This chart provides a clear view of the top-performing batsmen who've made a significant impact in IPL matches by consistently scoring runs. In this code, the first line groups the data by batsman and calculates how many boundaries each batsman has hit using the ag function with a custom lambda. This helps identify batsmen who have consistently hit boundaries in matches. After sorting the data in descending order, we take the top 10 batsmen and plot them on a bar chart with light blue bars. The batsman names are rotated for better visibility, and the auto-label function shows the exact boundary count above each bar, allowing us to easily identify the top boundary scores in IPL. In this code, the first line is key as it groups the data by batsman and calculates how many sixes, runs equal to 6, each batsman has hit using the AGG function with a lambda. This gives us insight into batsmen who are known for hitting big sixes. After sorting the data in descending order, we select the top 10 batsmen and plot them on a bar chart with light blue bars. The batsmen names are rotated for clear visibility, and the auto-label function displays the number of sixes above each bar, helping us easily identify the top 6 hitters in IPL. In this code, the first line groups the data by bowler and calculates the total number of balls each bowler has bowled using ag count. This tells us which bowlers have bowled the most in the IPL. After sorting in descending order, we select the top 10 bowlers and display them in a bar chart, where the number of balls bowled is represented by cyan bars. The auto-label function adds the count above each bar, making it easy to identify the leading bowlers based on their ball count in the IPL. This code calculates the number of dot balls bowled by each bowler using a lambda function. It groups by bowler and counts the zeros in the total and runs column, highlighting the bowlers who excel at delivering dot balls. After sorting the results in descending order, the top 10 bowlers are selected, and a yellow bar chart is displayed, showing how many dot balls each bowler has bowled. The auto-label function is used to display the exact count on top of each bar for easy reference. We're using SNS.CountPlot to visualize different dismissal kinds, showing the distribution of dismissals in the dataset. Rotating labels helps improve readability. And that's a wrap on our exploratory data analysis. We've uncovered some key insights, but this is just the beginning. If you want to dive deeper, stay tuned for our upcoming video on Scikit-learn. Click on the screen to continue and don't forget to subscribe. See you in the next one.